Dear student, today I will discuss a new chapter, that is your electrochemistry. It is a very important chapter. Electrochemistry is the branch of chemistry which deals with the study of chemical changes due to electric current. All the electrochemical reaction belongs to the electron transfer reaction. And all the redox reaction belongs to the electron transfer reaction. That means all the electrochemical reaction are redox reaction. At first, I will discuss about the electrolyte. Electrolyte are the substance which able to conduct electricity in aqueous state, or molten state, or fused state. That means a substance if conduct electricity in aqueous state, then that substance is considered as electrolyte. Or a substance in molten state or fused state, if the substance able to conduct electricity, then the substance is called electrolyte. Electrolytes are the ionic compound. That means we can think about the example like NaCl, KCl. These are the electrolytes which can able to conduct electricity in aqueous state or molten state or in fused state. When we apply electric current, then the electrolyte undergoes decomposition, and after decomposition, the electrolyte able to form the ions. There are two types of ions are formed. One is your cation, another is your anion. If you think about the electrolytes are of two types. One is your strong electrolyte, another is your weak electrolyte. One is your strong electrolyte, another is your weak electrolyte. Let me discuss about the strong electrolyte and weak electrolyte. Strong electrolyte are completely undergoes dissociation. But remember, weak electrolyte slightly undergoes dissociation. If you think about the degree of dissociation of strong electrolyte, then the degree of dissociation of strong electrolyte is equal to 1 or nearly equal to 1. But in case of weak electrolyte, the degree of dissociation is very small as compared to the 1. The degree of dissociation is indicated by alpha. So here you can write alpha equal to 1 or nearly equal to 1. Here we can write alpha smaller than 1. Then what is the meaning of degree of dissociation or degree of ionization? Degree of dissociation indicated by alpha. Suppose I will take 10 molecules. Among the 10 molecules, suppose 9 molecules undergoes dissociation. I will take totally 10 molecules for dissociation. Among the 10 molecules, suppose 9 molecules undergoes dissociation. They are completely dissociated. Then the degree of dissociation is equal to 9 by 10. Suppose I will take 20 molecules. Among the 20 molecules, suppose 18 molecules undergoes dissociation. Then the degree of dissociation is equal to 18 by 20. Suppose I will take 10 molecules. Among the 10 molecules, suppose 1 molecule undergoes dissociation. Then the degree of dissociation is equal to 1 by 10. So we can write degree of dissociation is equal to number of molecules dissociate divided by total number of molecule taken for dissociation. Taken for dissociation. You can write number of molecule broken into ions divided by number of molecule dissolved. In case of strong electrolyte, the electrolyte undergoes completely dissociation. That means if you will take 10 molecule, then out of the 10 molecule, if 9 molecule undergoes dissociation, then the degree of dissociation is equal to 9 by 10. You will take 10 molecules, and out of the 10 molecule, if 10 molecule undergoes dissociation, then the degree of dissociation is equal to 10 by 10. In this case, the degree of dissociation is equal to 1. In this case, the degree of dissociation is nearly equal to 1. So, we can write the degree of dissociation in case of strong electrolyte is equal to 1 or nearly equal to 1. But if you think about the weak electrolyte, in weak electrolyte, the electrolyte undergoes slightly dissociation. That means if you take 10 molecule, out of the 10 molecule, only 1 molecule or 2 molecule or 3 molecule undergoes dissociation. If 1 molecule undergoes dissociation, then I can write the degree of dissociation is equal to 1 by 10. That is 0.1, which is very small as compared to the 1 value. If 2 molecule undergoes dissociation out of 10 molecules, then the degree of dissociation is equal to 2 by 10. In that case, the degree of dissociation alpha is equal to 0.2, which is also small as compared to 1. So in case of strong electrolyte, the degree of dissociation is equal to 1 or nearly equal to 1. In case of weak electrolyte, the degree of dissociation is very small as compared to 1. Now I will explain about the dilution. What is the relation of dilution with the degree of dissociation of strong electrolyte and weak electrolyte? Dilution means addition of the solvent molecule. In this case, aqueous solution is taken. So we generally think about the solvent like water. Suppose I will add water molecule more and more in case of a strong electrolyte, then what will happen? Look at that. In case of strong electrolyte, suppose I will take 10 molecule. Among the 10 molecule, 9 molecule undergoes dissociation, or out of 10 molecule undergoes dissociation. Nothing is present to undergo dissociation. In this case, only 1 molecule is remain to undergo dissociation by the help of dilution. Look at that. In this case, there is no molecule is remain for dissociation. So when we will subject the strong electrolyte for dilution, there is no further dissociation. That means from this concept, it is clear that if no molecule remain for dissociation, then it is clear that there is no change in the value of degree of dissociation almost. That means the value of degree of dissociation in case of strong electrolyte is almost constant on dilution. So we can write the value of degree of dissociation for a strong electrolyte almost constant on dilution. Look at that. In this case, some molecule is remain for dissociation. When we will add solvent like water, then the remaining molecule undergoes dissociation. As a result, the value of degree of dissociation increases appreciably on dilution. So we can write in case of weak electrolyte on dilution, the value of degree of dissociation changes appreciably. We know that according to law of chemical equilibrium, K is equal to concentration of the product divided by concentration of the reactant. In this case, K is equal to concentration of the ions divided by concentration of the undissociated electrolyte. In strong electrolyte, the undissociated electrolyte is very less. So in this case, the R tends to 0. That means maybe R equal to 0 or R having some small value. That's why in case of strong electrolyte, the law of chemical equilibrium is not applicable. But if you think about weak electrolyte, in weak electrolyte, some undissociated electrolytes are present. So, in this case, the law of chemical equilibrium is applicable. In strong electrolyte, more amount of ions are produced. As a result, the conductivity of strong electrolyte is very high. In this case, small amount of electrolyte undergoes dissociation. As a result, very few amount of ions are produced. That's why the conductivity of weak electrolyte is very less. If you think about the dilution, after dilution, the degree of dissociation almost constant. That means we can think about that there is no relation between the dilution and the degree of dissociation of a strong electrolyte. But in case of weak electrolyte, after dilution there is a appreciable change of degree of dissociation. So we can think that there is a correlation of degree of dissociation with the dilution. If you think about the difference between strong electrolyte and weak electrolyte, first point is the strong electrolyte undergoes completely dissociation, while the weak electrolyte undergoes slightly dissociation. The second point is in case of strong electrolyte, the degree of dissociation is equal to 1 or nearly equal to 1. But in case of weak electrolyte, the value of degree of dissociation is very small as compared to 1. The third point is in case of strong electrolyte on dilution, the degree of dissociation almost constant. But in case of weak electrolyte on dilution, the value of degree of dissociation changes appreciably. Fourth point is the law of chemical equilibrium is not applicable, but in case of weak electrolyte, the law of chemical equilibrium is applicable. Fifth point is the conductivity of strong electrolyte is high, but the conductivity of weak electrolyte is very low. Sixth point is there is no correlation between dilution and the degree of dissociation of strong electrolyte, but in case of weak electrolyte, there is a correlation of degree of dissociation of weak electrolyte with the dilution. These are the difference between strong electrolyte and weak electrolyte. Now I will explain about the electrolysis. Electrolysis is the process of decomposition of the electrolyte into ions in aqueous state or molten state or in fused state by the passage of electric current. That means when we will apply electrical current to the aqueous solution of the electrolyte or the electrolyte present in the molten state or fused state, then the electrolyte undergoes dissociation into ions. There are two ions are produced, one is your cation, another is your anion. So we can write the process of decomposition of the electrolyte into ions in aqueous state or molten state or fused state by the passage of electric current is called electrolysis. Now I will explain about the description of electrolysis. For electrolysis, we generally take an electrolytic can. The container in which the electrolyte is taken, that is called electrolytic tank. Suppose I will take a molten NaCl as the electrolyte in this tank. Here NaCl is present. The NaCl is present the molten state. Two metallic rods are dipped in the electrolyte. These are called electrodes. There are two electrodes. One is your cathode, another is your anode. At anode always oxidation takes place. At cathode always reduction takes place. Now the two electrodes are connected with the battery. This is your said to be DC battery. The positive part is attached to this electrode and this is your said to be anode, and the negative part attached to this electrode, that is your said to be cathode. When electric current is supplied to the molten NaCl electrolyte, then the NaCl undergoes dissociation, gives a Na plus and Cl minus. That means I can write NaCl gives a Na plus Cl minus. This reaction done in the cell, so it is considered as the cell reaction. This is your molten NaCl. Now the Cl minus goes to the anode and oxidation reaction takes place. That means the Cl minus gives the Cl plus electron. Look at that, your loss of electron takes place. As a result, oxidation takes place at anode. So you can write at anode Cl minus gives Cl plus electron. This is your said to be primary process. The Cl atom is now unstable, so the Cl atom combined with the another Cl atom form the Cl molecule. This is your said to be secondary process. At the same time, Na plus ion goes to the cathode and reduction reaction takes place. That means Na plus electron gives Na. This is your solid. So we can write at cathode Na plus electron gives Na. Look at that, your gain of electron takes place. So we can think that reduction always takes place at cathode. Due to oxidation, the Cl2 molecule liberated at anode and the electron deposited at that electrode. As a result, the electron density on anode goes on increases. Due to reduction, the cathode supply the electron to the Na plus. As a result, your electron density goes on decreases. Your electron density more, your electron density less. That means the electron flow from anode to cathode like this. That means this is the direction of flow of electron. We know that the current always flow the opposite direction of the electron. So this is the direction of flow of current. That means current enters to the electrolyte at anode and leaves the electrolyte at the cathode. It is bound to write the cell reaction at anode, reaction at cathode, otherwise mark will be reduced. The movement of the ions to the opposite electrode is called electrolytic conduction. Remember an important point, there are also two types of electrode. One is a negative electrode, another is a positive electrode. Negative electrode means that electrode in which the electron density is more. Positive electrode is that electrode in which the electrode density is less.
In this electrolytic cell, the anode is your positive electrode while the cathode is your negative electrode.
Now I will explain about the application of electrolysis. What are the application of electrolysis? First application is your electrolysis is applied in electrotyping. Second application is electroplating. Electroplating means we think about the decoration. Second is protection. Third is repairing. Next application is electrolytic extraction of metal. Next application is electrolytic refining. Next I will discuss about the selective discharge of ions, that is also considered as the product of discharge. Suppose I will take an molten NaCl as an electrolyte. Then the molten NaCl breaks into 2 ion Na plus Cl minus by passing electrical current. This is said to be cell reaction. At anode, I can write Cl minus gives Cl plus electron. This is your primary process. Then the Cl atom combined with another Cl atom from the Cl molecule. This is your secondary process. At cathode, the Na plus gain 1 electron gives Na. This is your said to be electrolysis of molten NaCl. Suppose I will think about the electrolysis of aqueous NaCl. At first I will write the cell reaction. NaCl gives Na plus Cl minus. Look at that, your water is taken. As a result, we can able to form the aqueous NaCl. So here we can also write another cell reaction, that is your H2O gives H plus OH minus. Look at that. In this case, one cation, one anion is present, and this cation goes to the cathode, and this anion goes to the anode. But look at that. In this case, 2 cations are present, also 2 anions are present. Then a question will arise: which cation goes to the cathode first, and which anion goes to the anode first? This can be explained by the help of selective discharge of ions. So remember an important point: when 2 or more cation or anions are present, then the selection of ions for discharge depends upon 3 factors. One is your concentration, second is your nature of electrode, third is your discharge potential. Discharge potential. Now I will explain about the concentration. Higher the concentration of both cation and anion promotes its discharge. That means among the 2 or more cations, the cation which having higher concentration, then it first discharge. That means the anion or cation which having higher concentration, then that cation or anion discharge first. Next is your nature of electrode. Electrodes are also classified into 2 types depending upon the nature of electrode. One is your attackable electrode. It is also called reactive electrode. It is also called active electrode. Second is your non-attackable electrode or inert electrode. The attackable electrode attack to the electrolytic solution, while the non-attackable electrode do not attack the electrolytic solution. The example of attackable electrode are copper, nickel, silver, etc. The example of non-attackable electrode are graphite, platinum, palladium, rubidium, osmium, etc. Remember an important point: attackable electrode affect the product of electrolysis, while non-attackable electrode do not affect the product of electrolysis. Next, I will discuss about the discharge potential. According to principle of preferential discharge theory, if an electrolytic solution contain two or more ions of similar charge is electrolyzed, then the cation or anion which having least discharge potential discharges first. Discharge potential is the energy which is required to an ion to be discharged and converted into neutral species. According to this principle, if there are two cations are present, among the two cations, the cation which having least discharge potential, that discharge first at cathode. Suppose I will take two cations, one is your K plus, another is your Ca2 plus. Experimentally it is seen that the Ca2 plus ion having less discharge potential as compared to the K plus, so the Ca2 plus ion discharge first. Like that, you can also compare the another cations with each other. The another cations are Na plus, Mg2 plus, Zn2 plus, Fe2 plus, Pb2 plus, H plus, CO2 plus, Ag plus, AO3 plus. Among all these cations, AU3 plus having less discharge potential, so AU3 plus discharge first. If I want to arrange the cations according to the increasing order of their discharge, then I can write K plus smaller than Ca2 plus, smaller than Na plus, smaller than Mg2 plus, smaller than Zn2 plus, smaller than Fe2 plus, smaller than Pb2 plus, smaller than H plus, smaller than CO2 plus, smaller than Ag plus, smaller than AU3 plus. Suppose I will take two cations, Na plus, another is your Zn2 plus, then among Na plus and Zn2 plus discharge first because it have less discharge potential than the Na plus. So it is discharge first, then Na plus. Your AU3 plus having least discharge potential, so it discharge first as compared to Ag plus, as compared to CO2 plus, as compared to the other cation. But K plus ion having high discharge potential, so it cannot discharge fast as compared to the other cation. This is the increasing order of discharges of cation. Like cation, we can also write an order for anion. The increasing order of discharge of anion. SO4 2 minus smaller than NO3 minus smaller than OH minus smaller than Cl minus smaller than Br minus smaller than I minus. That means I minus having least discharge potential as compared to the other anion. So I minus discharge first. It is bound to remember these two order, otherwise you cannot write the reaction at cathode and the reaction at anode. Now I will explain some examples of electrolysis. First example is your electrolysis of molten NaCl by platinum electrode. At first I will write the cell reaction. The cell reaction is your NaCl gives a Na plus Cl minus. Your molten NaCl is taken for electrolysis. So one cation, one anion is present. There is no necessary for the selection of ions for discharge. So we can write at anode Cl minus gives Cl plus electron. This is your primary process. Next is your Cl plus Cl gives Cl2. This is your secondary process. And at cathode we can write Na plus electron gives a Na. This is your said to be primary process. This is your said to be secondary process. This is all about the reaction related to the electrolysis of molten NaCl. Second example is your electrolysis of aqueous NaCl by platinum electrode. Cell reaction is your NaCl aqueous gives a Na plus aqueous plus Cl minus aqueous. Another reaction also possible. H2O gives a H plus OH minus. Look at that here, two cation, two anion are present. So it is highly necessary to select ions for discharge. At first I will think about the concentration. Here no concentration term is given. So the selection of ion for discharge is not affected by the concentration. Now I will think about the nature of electrode. Here platinum electrode is given. The platinum electrode is an inert electrode. It will not affect the product of electrolysis. So it is not necessary to take the effect of nature of electrode for the selection of ions for discharge. Next I will apply the discharge potential. Remember this order. This is the order for cation, this is the order for anion. Now apply this order to this example. Now I will apply the anion order for this example. Here OH minus is present, here Cl minus is present. The Cl minus discharge first according to the order, because the Cl minus having least discharge potential. So I can write at anode Cl minus gives Cl plus electron. This is your primary process. Next is your Cl plus Cl gives Cl2. This is your secondary process. Among Cl minus and OH minus, Cl minus discharge first. Either is your such type of reaction takes place at anode first. Next, I will think about the cation. Your two cation are present. One is your Na plus, another is your H plus. Na plus is present here, H plus is present here. According to the order, H plus discharge first, because H plus having least discharge potential. So I can write at cathode H plus electron gives a hydrogen. This is your said to be primary process. Next is your H plus H gives a H2. This is your secondary process. If H plus discharge first, then such type of reaction takes place at the cathode first. Next example number 3 is your electrolysis of very dilute aqueous NaCl solution by platinum electrode. At first I will write the cell reaction. NaCl aqueous gives Na plus Cl minus. Another is your H2O gives H plus OH minus. Look at that. Your dilute aqueous NaCl is written. That means your more amount of water is present. As a result, more amount of H plus and more amount of OH minus is formed. In this case, the concentration of OH minus is more than the concentration of Cl minus, and also the concentration of H plus is more than the concentration of Na plus. At first, I will apply the concentration effect for the selection of ion for discharge. Among H plus and Na plus, the concentration of H plus is more than the concentration of Na plus. So H plus discharge fast. So I can write at cathode H plus plus electron gives a hydrogen. This is your primary process. Next is your hydrogen plus hydrogen gives a H2. This is your secondary process. Now I will think about the anion. There are two anion are present. One is your Cl minus, another is your OH minus. Among Cl minus and OH minus, the concentration of OH minus is more than Cl minus. So OH minus discharge fast. So I can write at anode 4 OH minus gives it 2H2O plus O2 plus 4 electron. Next example is your electrolysis. Electrolysis of aqueous NaCl by mercury electrode. At first I will write the cell reaction. NaCl aqueous gives Na plus Cl minus. Another is your H2O gives H plus OH minus. Look at that. Here NaCl plus water is taken as an electrolyte. Here mercury electrode is taken. Both cathode and anode are mercury electrode. Here battery is connected. This is your said to be plus. This is your minus. This is your anode. This is your cathode. Here no concentration term is given, so the concentration do not affect the selection of ion for the fast discharge. Think about the anion, that is your OH minus, Cl minus. Cl minus is present here, OH minus is present here. Cl minus discharge fast because Cl minus having least discharge potential. So we can write at anode Cl minus gives Cl plus electron. This is your primary process. Next is your Cl plus Cl gives Cl2. This is your said to be secondary process. Remember, your mercury electrode is present. Mercury have high tendency to react with sodium to form the amalgam. Mercury have less tendency towards the H plus. So in this case, Na plus is discharged first, then the H plus. Here the nature of the electrode affect the electrolytic solution. So we can write at cathode Na plus electron gives Na, then Na plus Hg gives Na Hg amalgam, that is your sodium amalgam. This is your amalgam. Now this amalgam react with the water, form 2 NaOH plus H2 plus Hg. In this case, we cannot apply the discharge potential concept because the mercury is more reactive towards the sodium. That's why the sodium ion discharge fast to the mercury cathode. Next I will discuss about the example number 5. Electrolysis of aqueous copper sulfate solution by platinum electrode. At first I will write the cell reaction. CuSO4 aqueous gives Cu2 plus SO4 2 minus. Another is your H2O gives H plus OH minus. Your no concentration term is given, so the concentration do not affect the selection of ions for the first discharge. Platinum is an inert electrode, so it do not affect the product of electrolysis. Now I will apply the potential discharge. At first I will think about the Cu2 plus and H plus ion. Look at that, here Cu2 plus is present, here H plus is present. From this order it is clear that Cu2 plus discharge first, because Cu2 plus ion having least discharge potential, so we can write at cathode Cu2 plus 2 electron gives Cu. Next I will think about the anion. Here 2 anion are present, one is your OH minus, another is your SO4 2 minus. Look at that, here SO4 2 minus is present, here OH minus is present. From the order it is clear that OH minus discharge first, because OH minus having least discharge potential, so we can write at anode 4 OH minus gives 2H2O plus O2 plus 4 electron. Next I will discuss about the example number 6. Electrolysis of aqueous copper sulfate solution by copper electrode. At first I will write the cell reaction. CuSO4 aqueous gives Cu2 plus aqueous plus SO4 2 minus aqueous. Another cell reaction is your H2O gives H plus OH minus. Suppose I want to draw the diagrammatical representation. Here CuSO4 plus water is present. Here copper electrode is present. This is your anode. This is your said to be cathode. This is your copper. This is also copper. Here battery is connected. This is your plus, this is your minus. Here no concentration term is given, so the concentration term do not affect the selection of ions for the first discharge. Now I will think about the nature of electrode. Here copper electrode is present. Copper is an attackable electrode. That means it affects the product of electrolysis. At first I will think about the cation. Here two cation present. One is your Cu2 plus, another is your H plus. Look at that, here Cu2 plus is present, here H plus is present. From this order it is clear that Cu2 plus discharge first, so I can write at cathode Cu2 plus 2 electron gives Cu. Next I will think about the anion. Your SO4 2 minus, your OH minus is present. Look at the cell. Here gradually Cu2 plus ion goes on decreases and it is deposited at the cathode. In this electrolytic solution, the concentration of Cu2 plus ion goes on decreases. As a result, the copper electrode which is taken as an anode react with the more concentrated SO4 2 minus ion. Here the copper electrode affect the electrolytic solution. The copper electrode react itself with the SO4 2 minus ion to maintain the neutrality in electrolytic solution. That means I can write at anode Cu solid gives Cu2 plus 2 electron. In this case the electrode play an important role. In this case we cannot apply the concept of discharge potential. These are the examples to explain the selective discharge of ions.